Hello all, welcome back to Free Engineering School. Hope you are doing fine and safe in this pandemic situation. Today we are going to discuss about the FEA process flow. As you can see, this is the FEA process flow. This is very generic and this is the main fundamental or foundation for all the FEA analysis. Like if you take a structural analysis or transient, dynamic, whatever the analysis you build in your FEA tool, but the basic funda should be understand with respect to this flowchart. There are three main categories here. One is uh, physical problem to be understand, and then this dotted is completely for dotted box is completely for finite element analysis, and then interpolation of the result and optimization. So going forward to understand the physics of the problems, whatever the FEA problems you are solving, before that we need to understand the background of the study, how the model is, how the assembly will behave, or what are the types of loadings are coming in, and what is the boundary conditions are involving, what is the expectation from the main model can be understand. So once it is clarified, then we need to go for the some of the assumptions which is governed by the differential equations. I will take some further in detail discussion on the selection of differential equations with respect to the particular analysis type. So in these assumptions, we need to consider the geometry, what are the kinematics are involving in that assembly, if you are taking the assembly components, what are the material law, whether the component is going to be under plastic zone or elastic zone, and what are the loading type which is acting in the component, and boundary conditions, etc. If you see in the left side, this is a simple flange component which is fixed at the left side, and we are applying a point load in the downward direction. And the we need to discuss about the more on element types and then boundary conditions in detail. I will take it in the next discussion. Just we need to, for your simplification, just I put this simple model. So you can see we'll call it as an elements which is connected by the nodes. So this is like a physics of the problems has been converted into FEA solutions. Here we constrained it and we are applying a downward direction of load, and uh, based on the loading condition, how it will be behaved can be analyzed in the coming slides. So here, once the mathematical model has been freeze, then we'll go for the finite elements on a solution. This will usually will call it as a pre-processing. In the pre-processing, we need to understand what type of elements can be used, and what is the element size, and where are the main particular parameter to be considered, where is the main concentrated zone to analyze for the results. So that can be considered, and then we need to go for the FE modeling. Then after we need to represent the loading condition as I shown here. Here we are applying a load of point load with respect to this hole, and here we have considered this is the boundary conditions we need to be captured. All this process can be done by using Hypermesh, ANSYS, SimLab, ANSYS as well for the pre-processing tool. You can use it. Then after we need to go for run the model. Once the model setup is done, we need to run the simulation to see the behavior and the outputs. So to run the simulations, we need to use Abacus, ANSYS or MSS software tools to run the simulation. Once you get a simulation, we need to see the results, how the component has been behaved with respect to our applied load. In this, we need to consider what are the stress affected, and what are the displacement and reaction forces which are applied is going in the correct way or path. Forced run, if you get any results which is not satisfactory with respect to the physical problems, then we need to go for refining mesh and applying the boundary conditions in changing the boundary conditions, and if you want to change the solution parameters, that can be changed, and then further you need to run the simulation. Post that the run, if you satisfied with respect to the physics of the problems or physical model of the problem, then we need to go for refining the analysis type if not satisfied with respect to refining measure solution parameters. So this refining analysis is further going back to the improvisation of the mathematical model. Suppose the whatever the results we got is that is not satisfied, then we need to go for refining the analysis itself. Instead of going for this refining measure solution parameters, we can go for refining analysis itself by considering this mathematical model or resynthesizing the parameters assumptions made by in the initial step. So in this improving the mathematical model, again we need to see the geometry and material laws which we are consider whether we have applied correct load or boundary conditions. Post that, again we need to rerun the simulation as I discussed here. Once the results are satisfied, we need to see the output like stress and displacement with respect to the applied forces. So suppose if the component is carrying heavy load, still it can be withstand with respect to the high stresses. We can go for optimization where we can see the weight reduction capability or something. So post optimization, you can further redefine the model with respect to the change in physical problem. Suppose if the loading condition is still further can be applied, for example, we are applying a 10 kilonewton for this flange. If even if you apply for 20 kilonewton also, it can be withstand. Then we need to go for structural optimization to in order to make it for only 10 kilonewton. So this is the weight reduction capability. We can do it in our FEA analysis. So this is the simple process flow you can follow up for each and every analysis which you are going to do in FEA. So that's all about the FEA process flow. Please write your comments or any questions in the any questions coming from your side. It can be appreciable. Thank you.